Intrinsic type of semiconductor material is in pure form, means it is made up of only one single type of element. The presence of impurity, means atoms of other material, is very low, and therefore they are equivalent to insulators or very poor conductors. Germanium, silicon are the most common types of intrinsic semiconductor elements. Semiconductors that are chemically pure, in other words, free from impurities, are called as intrinsic semiconductors. The number of holes and electrons is therefore determined by the properties of material itself instead of impurities. In intrinsic semiconductor, the number of excited electrons is equal to number of holes, and therefore they are termed as undoped semiconductor. Now let's go for extrinsic semiconductor. Extrinsic means impure. We can say that intrinsic semiconductor plus added impurity is equal to extrinsic semiconductor. The process of adding impurity to the pure semiconductor is called as doping. Due to doping, the conductivity increases. Two types of dopants are used. Pentavalent atoms means the atoms with valency 5 such as arsenic, phosphorus, antimony, etc. Or trivalent atoms means atoms with valency 3 such as indium, aluminium, boron, etc. So this is about extrinsic semiconductor. Now let's compare intrinsic and extrinsic semiconductor. Here the comparison of intrinsic and extrinsic semiconductor is given. Intrinsic is pure type of semiconductor because there is no impurity present. Extrinsic is impure. In case of an intrinsic, the density of electrons is equal to density of holes, means number of electrons is equal to number of holes. But in case of extrinsic, it is not equal. In intrinsic semiconductor, as it is a pure semiconductor, the electrical conductivity is low. So, or in extrinsic, we can call as electric conductivity is high. Intrinsic are dependent on temperature only. Extrinsic are dependent on temperature as well as on the amount of impurity. And as I told you, in intrinsic semiconductor, no impurities are present. But in case of an extrinsic semiconductor, trivalent and pentavalent impurity we can use.